I want to talk today about my general style of lecturing, or my general style of also speaking is a kind of narrow down. So I start from very large and then I go directly to the point. So I will start with a general introduction about what I think is the future trend of IT. And then in particular, what we are doing to support this trend, to encourage it also. So thanks to Sergey, also my university, Innopolis University, is a partner of the school. And maybe some of you know the University of Innopolis. This is the building. In summer, in winter, it looks different. It's all white and all snow. And actually, those stairs are slippery and dangerous. But in summer, it looks great. So what do we do all the day at Innopolis? I think it's not very different from any other academic organization. Of course, we drink coffee because it's one of the things that we missed the most during the pandemic, drinking coffee with the colleagues. Sometimes it's tea, it's not coffee. But yeah, I mean, coffee is not just coffee. Coffee is really an enabler of socialization. No, this is kind of well known by Napolitans, no, by the people living in Naples, that coffee is one of the major socializing aggregators. The same in every academic environment. But apart from this, we do education and research on IT. I was undecided until the last minute if I should have given here a talk on the education part, the technological part of education, which has had a significant progress in the last couple of years, because now education and IT are very much merged into each other. Before, education was using IT to do things, to provide the material to the students. Of course, we use the instruments like computers, projectors, maybe Skype and so on. But in the last 2 years now, the two things became very much one thing. So it was also interesting, maybe in another occasion, to talk about that part of our work. But today I will talk, of course, on the research part. And to do this, I will use this narrative way that I have, to narrate the stories. And I start from the general, then going to the particular. So you will see the specific research that we are working on in the second part. In the first part, I want to try to engage people with a larger discussion that can generate questions. And maybe we can have a small question session at the end of the first part. But in any case, you can interrupt me at any time. I don't easily follow the hands, the raised hands in Zoom. So if you want to interrupt me, it's better just to jump in, switching on your microphone like in the old days. So it's obvious that all these futurist people for the last 20 years, they were talking about acceleration of something, that definitely the technological advancement that we have seen in the last 50 years is much bigger than what we have seen in the previous 50 years. But if you look at the last very few years, including the last 2 years, major crises led to even faster acceleration. So it's true that we are really living in a time in which not only the technology is developing fast, but it's also the adoption of the technology that is moving fast, because definitely these are two different problems. The development of the technology that depends on specific research, development, industrial process, and so on, and the adoption. The adoption is a completely different business. No, if you look in different countries, how personal computers were adopted, or mobile phone were adopted, or smartphone were adopted, you can see very different trends that depend on the demography of the place, the social environment. So don't give it for granted that if you have a great technology that is developing fast, this technology is also adopted equally fast. And this is the bottleneck. But in the last few years, we have seen also an acceleration of the adoption of the technology. So where are we going? And especially, who is leading the change? So what are the technologies now that the major IT companies, those that can really invest in research and development, are pushing? Where they are investing money, where they are spending money to develop what? And what are the technologies that will become pervasive in our life and kind of unavoidable in the next 10 or 15 years. Okay, so in the last few years we had already an intuition about it. Obviously, every time that you introduce a technology, there are also a lot of philosophical and ethical aspects. In particular, now in recent years, a question that I ask every time there is typically a PhD presentation, no? I mean, some junior researcher. I don't always ask this question to senior researcher, but in every context in which there is a junior researcher, a master student, or a bachelor student presenting their thesis or their work, and they develop something, typically my last question at the end of the seminar is always, how do you see the dark side of your work? So how your work can be misused? And I think this is a question that we should always ask ourselves, no? Because every technology has a good use, but can also have a bad use. And it's important for the students start thinking also about this. So I will take an example about the technology, an example that is very common, no? Because if you start talking about something that is very specific, it may be well understood by some people, less by others. I'm not completely sure about the background of this audience, because there is this link, and I suppose that has been shared, and I hope that virtually anyone can attend this event. So I don't assume much. I'll talk about cars. Cars, I think, is sufficiently old technology that probably all of us tried once, even those that don't have a driving license. They drove a car, and maybe they've seen a car like this or something similar. Okay, this is a car about 35 years ago, let's say beginning of 80s. Car looked like that, no? Now here I'm not talking about the trend about the shapes of the car. The modern car, they look differently, but I'm not focusing on how they look in terms of shape, of design, no? There is a theory that says that when the economy is booming, cars tend to have more sharp shapes, and when it's not, they tend to have more feminine shapes. But this is not the point. So look at Lada, no? The Lada. So we all know this beautiful car. This is actually a Fiat, is an Italian design. It's a very, very cute car that you still see around. Here in Kazan, we see this car sometime around, and this, you can buy it for very little money. But look at this car and consider the difference between this car and this car. Okay, of course, they are both recognizable as a car. So if an alien today is landing on the planet Earth, probably will recognize that these two pieces of technology are kind of the same, no? It shouldn't be impossible to understand. But what you don't see is that the difference in between the new car and an old car is big, even if it's not immediately visible. However, there is no substantial change to the concept of car outside the cabin or in the surrounding infrastructures, like the streets, for example, at least so far, because now I'm not really taking into account the full deployment of autonomous vehicles that would change the story again. But even without going to that, we see that a car is still a car, but the revolution happened inside the cabin. What does it mean inside the cabin? So what is there now that it was not there before? Look at some examples of technologies that became completely widespread in the last 10 years, because 15 years ago, something like adaptive cruise control was pretty much only in very expensive car, kind of luxury car. But now you see all these kind of things are pretty much affordable. So what is the keyword that the word that can summarize these three things? No, startup system, cruise control, adaptive cruise control. Some people will say the electronic. Will say that the electronic entered into the car, which is true. But from our point of view, as a computer scientist, we have to say, and we have to realize and notice the fact that basically it's the software that entered the car and didn't enter only the car, entered especially the car, but software now is entering literally every device that before was mechanical or electronic or electromechanical without software. You can think about television, a TV set, washing machine, anything else that is in your house. Your same house now to some extent as a software in it. No, we don't really see major deployment of so-called smart cities and smart houses. Even in Innopolis, that is born to be a smart city, you go inside the apartments and they are not so smart as you may think. This is something still coming for the future. But for example, now more and more in the apartments, you see instruments like Alexa or Alisa, all these kind of instruments that are software assistants and personal electronic software assistants, stuff that I don't like particularly, but I have to realize that they are very useful. Kids like it. And there is also a dark side of it. This is why I always tend to emphasize this aspect of the dark side. But it's the first, probably the first element of one of the first elements of smartness in the house, together with the TV set, together with the mobile phones. And of course, software will enter more and more your house, our houses, and our lives, therefore. And we didn't say basically anything about the autonomous vehicles, because when before I mentioned the infrastructure, I say that not much changed outside the cabin, apart from the design shapes of the car, and not much in the surrounding infrastructure. I'm saying basically that, well, the streets are very similar to how they were 35 years ago. But when you consider autonomous vehicles, then there will be even bigger impact of software. Obviously, at this point is undeniable, no, that the big change is brought by software. So the next thing, well, let's say that is not only the next, is also the last, but let's say the next thing is software. Software, if you remember Andersen, he's the creator of Netscape. Maybe people that are a little bit older, they probably remember him, and they probably remember Netscape. Probably for some people was the first, is not the first browser existing, but maybe the first that some people used. And now software is not only inside the computer. At the time of Netscape, 95, 94, 96, software was for the regular person. No, I'm not talking about specific industries like aviation and so on, but for the regular person, software was something inside the computer. Think about 1992, 3, 4, 5, 6. The word software would have immediately brought your mind to the computer. And actually, in the kind of colloquial talk, when you talk to people, there is still this idea that software is computer and computer is software. So that software is something that is inside this desktop machine, or maybe now the laptop. But it's not like this. Actually, the idea of software completely now detached from the idea of the computer. My laptop is not just one of the numerous devices that operates through software. It's a completely different story. 25 years passed, and it's a completely different story. In this sense, software is eating the world. Is penetrating all the possible devices that before they were just electromechanical, maybe. And so software and computer are two words that are not that strictly connected as before. There's something different. Software is kind of growing, becoming mature, and leaving behind his father, that is basically the computer. There are some reflection to do, at the end of this introduction, because I told you I always like to think about the dark side of things. Also, the massive introduction, the massive penetration of the software in every element of lives, every aspect of lives, can also have some negative consequences. On one side, for example, it's very good that if you have a device that is based on software, the software can easily and regularly update. So you have always the last thing. But among also, I don't want here to discuss all the pros and cons, because there are too many. I want to focus only on a couple of things. In particular, I noticed that the planned or induced obsolescence of a device becomes much more effective when there is software. So it's much easier to have a TV set that becomes outdated, that becomes old, or a mobile phone if there is a software in it. I remember that I had in my house in Italy the same TV set in one room from 1988 or 89 to 2015, and it was working perfectly. When it broke, it broke. Okay, but when there is a TV set with software, things are different. So there are also negative aspects. We should consider that, but it doesn't mean that we want to deny the importance of penetration of software in every aspect of life. Look at this object. This photo is a photo of an house that I would guess, I don't know, I just took a random photo of a old house from the internet, so I don't know where this house is and how old it is, but I may guess that is beginning of 20th century, maybe I'm completely wrong, no? But this is definitely not a house that has been built in the last 20 years. Again, we can do the same mental exercise than that we did with the car. So look at this house. Look at the modern houses. What is the difference between the old houses and the new houses? Well, there are many differences. We can say that, among other things, there is a penetration of electronics in the car, in the buildings, in the houses. However, it's a little bit behind. This penetration of software didn't fully reach the buildings, at least in the way that we hope, in the way that we foresee, the way that we write in our papers, in our research. Because we are not yet there. The smart house is not what we idealize. It's something where, okay, we have smart devices in the houses, no? But they are still loosely connected with the house and somehow also loosely connected between themselves. So there is way to go in the automation of the buildings, and there is way to go in the automation of the cities also, the cities and the buildings, so that they should be interconnected. Now, you don't see really much of this these days. It's a vision. We recently wrote a paper surveying the state of smart cities in Russia. I can share this with you. But basically, what we realized that even those places that are courtier or cities like Innopolis, that are supposed to be the places where the smartness will enter the cities, even there is not that much integration of software for the buildings. So we are really at the beginning of this story. So at some point we can expect intelligent buildings. So the massive, not the minimal introduction, but the massive penetration of technology, and especially I mean software technology, inside the buildings, inside the houses, and in the way in which these different buildings connect and relate to each other. So this is the so-called smart city or smart community. So how it will change the interaction between people in the future, when this technology will become fully deployed. This is very interesting to imagine, but in the last couple of years, there was a significant acceleration of usage of instruments like Zoom and other things. So we may imagine also that the sociality of people is changing and will change even more with the introduction of intelligent buildings. I'm a kind of fan of movies from 80s and 90s because I'm getting old, and there are a lot of these movies about the future and about the future, how the future would look like. And an interesting movie to watch, I think, is Demolition Man with Sylvester Stallone. It's also fun because all the things that now we are hypothesizing and working on realization are also described in a sarcastic way in that movie, because the director has a kind of touch of sarcasm for this society living in very invasive technology environment. Talking about invasivity of software, the software wants to reach also our body, initially reaching devices that we can wear. There is a student of mine that is working on wearable devices for medical purposes, no? But this is just one little application. I think it's more interesting than that. We can really foresee a future where the software is serving our needs fully, basically being maybe even embedded in the body, but in an initial phase embedded in what we wear. And this is fun. This is very exciting if you think about it. No, personally, I've never experienced this level of intelligent wearing, apart from some small devices that you use for sports and stuff like this. But look at this photo, this picture, this T-shirt, the smart T-shirt. It's very exciting, you know, to have the possibility to experience such level of technology. One project that I worked a few years ago in Italy was about making smart a building, a house, an apartment for the supervision of old people. So this is one of the first applications that you think of. In that project, we didn't work on intelligent wearing. We worked only on the intelligent sensoring inside the house, with the camera and with other sensors to check the pattern of behavior of the people, and also some medical devices wearable to check some metrics, some biometric. And the next step, something that we didn't do, but it's easily thinkable of, is using intelligent wearing instead of just intelligent, just wearable devices, to monitor the health of a person that has some impossibility to leave the house, or maybe is old, or maybe is ill. So this is also has been seen also in the quarantine period in Moscow, for example, or maybe also in other countries where people in quarantine had to use an application with camera to check that they were in the quarantine and so on. So you see that the imagination, only the imagination can stop your can stop you from thinking of possible application of this technology. Again, privacy, or if you want to say in the British way, privacy and ethical problems are also something that we should always focus when we talk about this technology. So now what I want to do, this was a very general projection of what the future could be. And now I want to work to describe in the second phase more our little contribution in this big context. So what we are actually doing, what is intelligence for us, what is data for us, and what we can do concretely to realize this vision. This vision is very broad, is very big. And if you think about broad visions, you get lost easily, because you say, okay, how we're going to do all this? So you need to have the vision, but also you need to work little by little, day by day, to construct what is buildable right now. And so this is what I'm going to do in the second part of the talk. So I think this is good time to have a little short question time if you want, or maybe to do the 5 minutes break or 10 minutes break now before, or maybe 5, because otherwise I don't have enough time to say everything I want to say. 5 minutes break, or I can take questions at the moment. Sergey, what do you think?
You're the captain.
Okay, I think we can take some questions here if there is any, and then do 5 minutes break, and then we'll go into the second part. I think it's a good moment. It's not exactly 50% of the talk, it's probably 30, 40, but it's a good time for doing the break. You know, like in the movies, no, you put the publicity when it's the right moment in the narrative. Okay, if there is no question, okay, I think we can start in exactly 5 minutes from now. No, it's gonna be Moscow time 12:35. Okay. Sergey, still there?
Yeah, I'm there, but yeah. What do you plan to do during the break? Chat?
Yeah, I'm here. I'm here, available for. I'm here. So okay. If there is anyone that want to comment or say something, it doesn't need to be 5 minutes long, the break. If there is nothing, we can, in a couple of minutes, start again.
Yeah, I guess there is a question on the chat. If you
There
see
is
that-
a question. Interesting. There are a lot of movies like Clueless that I don't know, unfortunately, where touchscreens will show as if from 90s. So it's a bit of topic question, but do researchers get inspiration from movies or vice versa? This is very interesting. I think both. Definitely both. If you are a fan of Star Trek, the old style, you know, Star Trek before being a movie sequel was a TV series. I don't know if you know Star Trek from 70s. And basically they had mobile phones. I mean, they had a device, communication device that was mobile phones. So it's definitely true that the science fiction is inspiring the people in the sense that, but this is true in general. And I think before having a device, before having a technology, you need to have someone able to imagine such a technology. And the typically person imagining the technology is not a scientist immediately. I mean, there are other kind of people, other kind of visionary writers, philosopher, movie maker that they are imagining a technology. You know, they are really imagining a technology and representing it artistically without having the opportunity to realize it. No, I mean, I think it happened to all of us as a kid. Also, as a kid, I was imagining about some technology, how beautiful this device would be. And I think also watching Star Trek when I was a kid, I also thought, oh, nice, it would be nice to have this device to go around and talk to people, no? But then you cannot do it because to do it, you need the science and you need the engineering. So the artist, in this sense, the movie scripter, movie director, they are very creative people that they can visualize in their mind some technological object without having the opportunity to realize it. But later on, when the technology is ready, there will be some engineers or some group of engineers that taking inspiration from that imaginary invention, they can actually realize it. So definitely true that the scientists, the engineers are taking inspiration from the artists, because artists sometimes are more visionary, are more ahead with their imagination than maybe the engineer. If it's true the other way around, so if you are saying that on one side the artists are influencing the engineer, if the engineer are influencing the artist, it's also possible. So you are saying, for example, talking about Demolition Man, it's a very interesting movie because I think it's from 93. I was 17 years old. And they have virtual reality devices that I suppose they were very primitive at the time. So it is true that sometimes the imagination is kind of anticipating the reality. Do researchers get inspiration from a movie or vice versa? I don't know if it's vice versa. It's a very difficult question to know, because you would assume, so these artists are very visionary people, but not necessarily they have friends that are in engineering, but maybe sometimes it's possible that these people are talking with people in engineering or in science, that they are maybe discussing some latest advancement that is not yet there, and they can represent it on the cinema. But this is a very, very interesting topic. Actually, I would like to hear also your opinion. So I'll try to answer all the questions, and then maybe if you want to reply.
Can I have a question probably
Please,
from myself?
please.
Is there some kind of bias approach in terms of, like, if you read something that you already imagine it in this way, so your mind is kind of limited to this imagination? So for instance, so. If I never saw a car, then I read sci-fi movie or sci-fi, I don't know, book that describes the car. So potentially, if I try to create the car, I would have an image of this sci-fi car. But potentially, there could be a design that is more productive and better. But I automatically I limit myself in thinking by sci-fi writer.
This is also very interesting what you say, because on one side we said that the artists they have this great imagination and people are following, but there is also the dark side of this, in the sense that it's true. Then if the art, the movie, the cinema, the literature is creating some mindset, then it's also difficult to get out of it, you know. So in some sense, their imagination could also limit the technological development, because then you are chasing that direction instead of something else. So yeah, I think this is a kind of the dark side of it, that this imagination can become limiting, because people that have less imagination, they will follow the imagination of these people in some sense, you know. There is a question if there are efforts to prevent illegal and unethical use of such technologies. There is always effort to prevent illegal and unethical use of something, but I think we have to accept the fact that it doesn't matter how much effort is put. There is always someone smart, but on the dark side, that will do incorrect use of the technology. I mean, it has always been the case since the invention of the fire. I don't think there will be always any authority or organization that will be able to stop the illegal and unethical use. What can prevent it? It's always education. This is why today I'm not talking about education, but education is very much connected with what we are doing, in the sense that the only way really to prevent bad uses of technology is to educate the people in the school, and in particular in the university. My little question that I asked to every PhD student at the end of their talk: what is the dark side of your technology, how it can be misused? It's meant to put some seeds in their mind that it's a question that is worth thinking about. Because, I mean, when I was a PhD student, no one ever asked me this question. They asked me any sort of question, and never this one. But I think this is the first step to put people on track against the bad, illegal, unethical use of the technologies. Yeah, then there is Alessandro Benetti, like, yeah, very nice movie, of course. If you start talking about cinema, we completely go in another direction. Minority Report, Tron, sci-fi movie, Star Trek. Star Trek is one of my favorite, of course. Back to the Future, oh, yeah, absolutely. The design of black hole in Interstellar used physics concept in depicting it. So maybe that can be an example of science inspiring. Yeah, also true. It's a very, very interesting chat. No, I expected some discussion. So probably so it needed more than 5 minutes. I was not enough accurate in my prediction. But maybe we can move on. No, I think maybe we can move some other question to the end. What do you think, Sergey?
Sure. I mean, we will have quite enough time after the lecture.
Absolutely. So this is the first part of the talk that is very visionary. So also my talk is affected by the same realization that we had about movie. The first part is very visionary and very speculative, and the second part is very down to earth, you know, very, very concrete, and also maybe less interesting to some extent. But I'm telling you exactly what we are doing right now at the moment here. So I have to thank, of course, my colleagues. Mohammed Ahmad, at the moment, he's in Pakistan. Luis Araujo is working in Moscow in Huawei. And Salvatore Antonio are my colleagues at the University of Messina in Italy. So this work has been done also with them, and thanks to them. In general, the expertise of this specific team, this is a team of people, international team that I'm working, not specifically people that are in Innopolis. Of course, I also have other collaborations on other projects here in Innopolis, but now, today, I want to focus on this piece of work because I consider that can provoke some thoughts and some questions. But our expertise as a team, is, so I'm a software engineer. I know about software processes. I work on software quality. We work on DevOps. And the machine learning part is mostly my colleagues. So this is the mixed expertise, because what we are trying to do here is to work at the edge between software engineering and data science. We have a software engineering institute here. We have a data science institute. Unfortunately, they don't talk that much as they should. But definitely there is a lot of interesting research that can be done and should be done at the edge between software engineering and data science. And looking at connecting this part of the talk with what we have seen in the first part, we talked about progress, but in that kind of imaginative and speculative part of the talk, we were talking about what I called harder technology. You may not find this terminology, hard and soft technology, necessarily in the literature. It's something that I use. It's a terminology that I use. I don't know if anyone else is using it. Maybe, maybe not. I didn't find, but I make this distinction, a bit arbitrary, because the two things are connected, between hard and soft technology. So hard technology for me is what we have seen. Sorry, I need to got stuck. Yeah, hard technology is what we have seen in the first part of the talk. We were talking about products, items, devices. But to be able to produce effectively, industrially, in large number, in large quantity, and in a relatively short period of time, these devices, you need also to enhance your soft technology, soft progress. Soft progress, in my terminology, is not about the devices, is not about the release of a new telephone, but it's about, so it's not about the tangible product, but it's about the process. Okay, so in this rapid trend of technological development, to make it more and more rapid, more and more exponential, if you want, especially the automation, the global process of automation, because sometimes it's called digitalization, sometimes it's called automation. The two things are basically the same things. We are trying to automatize more and more. For this to be effective, you need process innovation. In software, we have seen the agile movement and so on. Then we have seen DevOps and many other things. So to produce better hard technology and faster, produce it faster, we need also better soft technology. So we need suitable processes. And in particular, to optimize not only the development, but to optimize the operations. This is something that we will talk about it a little bit later today. And yeah, things like fight for every single customer, having competitive prices. Though also this is part of the process innovation. And we have seen this process innovation emerging in the last 20, 30 years in several industries. But if you want to consider two industries that are particularly related to software, I would mention two. I would mention game industry and mobile application. These are industries that went from zero to hero. So the game industry in early 80s, or beginning of 90s, even if you want, up to some point, it was kind of semi-amatorial. Of course, there were companies, profit, making money. But if you look at the development of the game industry and also the mobile industry, it really went from zero to hero in no time, in 20 years or something like this. It's incredible, no? So it means that they are doing something right in terms of innovation, in terms of processes. So what is this innovation? This is soft innovation of soft technologies. And what are the role models? Now, to understand the reality, we need to understand who are the leaders of these realities. In some sense, the role models means that if tomorrow you want to create a new startup doing something, you probably want to look at what has been done before. We all need role models in business, in research, in life, in every situation. So I mentioned a couple of these role models, because at least a couple of case studies that are, I think, particularly interesting. I want to think about Uber and I want to think about Airbnb. These are also is the material for completely different talk. So I'm not gonna go into the details too much about it, but think about it. Uber is a taxi or an IT company? What is Airbnb? Is it an IT company or is a realtor? So now we give this stuff for granted, but think that a company like Uber doesn't basically own any car, and Airbnb doesn't own apartments. And also Uber is particularly interesting example of startup because, and this is true for other realities. So they identified a gray, semi-legal sector of the market. So I'm not saying that what Uber did at the beginning was illegal, but I would say that was under-regulated, was a little bit gray. So they stepped into the foot of the taxi drivers. In countries where taxi drivers, sometimes they have to buy expensive licenses because everything's very much regulated. Maybe they have to do medical checks. They have to do a lot of strict, they have to follow a lot of strict regulation. And without violating basically any law, they propose something that basically almost no one thought about it before. Well, at least in the form of an app, because the idea of informally bringing people from one place to the other of the city existed before, existed also in Russia. In front of the theater, a couple of cars would be there, and you stop them, and they bring you somewhere. But Uber is not an official taxi. It's something else. So they really captured this gray area of the market, and they started leading it, not without frictions, because in London, for example, Uber had problems. In other countries also had problems. But they started leading it, and is the example of a country that is leading the transformation of the legal framework. Because when something like this appears, then to some extent is the legal framework that has to adapt in a way or another. So this is an example of extremely progressive. So they don't own any car. They are even driving sometime the legal framework change. And they are an IT company, but it's too reductive, too little to say that these companies are IT companies. They are more than that. But the example, I show this example because I want to emphasize the fact of how difficult it is now to distinguish what is an IT company and what is not. 25 years ago, 20 years ago, 50 years ago was much simpler than that. No, IBM is an IT company, yes. Microsoft is an IT company, yes. And Uber, yes, is still an IT company, but you think how much becoming confusing. So the trend is that the borders of information technology are becoming blurred. So it's not so evident anymore. And this process will continue. So this separation between information technologies and the other businesses will become almost inexistent. So this border, I suppose, is destined to disappear. So this is, well, this is my hypothesis, okay? I think it will come because it's already happening. And since now I'm gonna focus, now narrowing down more and more using this narrative technique, I'm gonna go to the DevOps. This is where I want to get. Before talking about DevOps, I need to talk about deployment and releases. This is very important. In software engineering, when I teach courses in classic software engineering, sometimes deployment is the last bit and say, okay, now you have the code somehow, and you will deploy it. So it's a kind of last chapter, considered unimportant. However, it's becoming more important, more and more important. No? The perspective on the idea of release and deployment is changing dramatically in the last 10, 15 years. And we will see why. So when I was a teenager or a kid, I had this excitement of going to buy the new CD or the new music tape or the new software release of something. For example, those of us that are not that young will remember probably the epic Windows 25 or 98 and so on. So the funny thing here, the very exciting things that you had to go to the shop to get this stuff on some physical support. In 90s was typically a CD, in 80s was a floppy disk, in 70s was the flexible floppy disk and so on. So you had to go to some specific place to know some specific people and to get it. So these days, this will be considered something extremely uncomfortable and extremely inconvenient because we got used to the fact that we get the food delivery in 20 minutes, that everything is on Android or iPhone app, that you have automatic updates of software. No, the software is eating the world in this sense. So for us now, thinking that you have to go to a shop on the other side of the city, because when I was small, there was only one software shop every, I mean, you had to travel some time, some place. It's considered extremely inconvenient. However, this was extremely exciting too. So you have to understand that, you know, this is the always life, no, in terms of kind of natural law that when you gain something, you lose something else. It's hermetic principle. So it's definitely the case that we are losing that excitement. But let's forget about feelings now. Look at Google, or it can be Yandex, or it can be anything. So this is a web service. So what is the what is the release number of Google? So what kind of version you are using of Google at the moment? You can know it, of course. There is a way to know it, but it's not so straightforward and it's not so interesting either, because you understand that it's very different. It's 1995, you go to buy Windows 95. It's 1998, you go to buy Windows 98. It's year, I don't know, 2001. No, Vista is 2008, I think. Okay, so okay, and you go to buy Windows Vista. It's important to know when it's out, because you need to go and take it. Very, very simple. Like the CD of your last CD of your most favorite singer. Now is absolutely irrelevant. I mean, you don't need to know it. You may know it, you may not know it. It's not interesting. So you see that the idea in which release are generated is also changing. Look at the first picture here on the top of the slide, the traditional deployment. So you have something, an application, an operating system, and after a number of years, you have the new release with the new deploy and so on. And this, by the way, if you look at this picture on the top, this is also the way in which artistic artifact. I'm making the example. I'm doing the example of music, but you can consider other examples. Also for literature, well, this is the classic way of releasing. I'm a musician. My album is in 2001. Next album is in 2007. In the middle, I do concerts, but I don't do anything. But now you see that for software and also for other artifacts is very different, because basically there is no such a thing as a moment of release. There is a product that is in permanent evolution. So there are no such gaps. People, for example, artists, they don't need to wait 5 years or 2 years to do the new album and collect 15 songs or 10 songs. They just can do the release one song one by one over the period of 2 years. And this is actually what is happening. So we are seeing this change from this discrete moment in time in which something is happened to the permanent evolution. And this is part of the accelerating time, what we have seen at the very beginning. So we have seen this in a very visionary manner, not a very large and philosophical manner. But when it comes to the specificity of our job as a software engineer, we find the elements that in the everyday life, they make that vision reality. And this is of the permanent evolution of software is one of them. And so now deployment, that is the last lecture of software engineering course, where you say, okay, deployment code is complete, deployment, okay, do it. But we always focus in academically in teaching. Maybe we can say that our courses are a little bit outdated. This is true, but typically we teach that how you do software, how you are a software engineer. You do requirements, a lot of emphasis on requirement, a lot of emphasis on design, implementation, very important, test, very important, and more or less that's it. So deployment, maintenance, they are kind of last chapters of the book. And even the methodologies like Agile that were focusing on getting the code complete faster than with other methods, they still focus on completion of code. So they emphasize the code as the most important artifact, the completion of the code as a most important artifact. However, we know that code complete doesn't mean that the code is in production, because there is this little moment, little obstacle that is called deployment, that often neglected in the theory of software engineering too much, probably. There are problems that can occur, unfortunately, as you may have problem in the requirement phase, in the design phase, in the implementation phase, in the testing phase. There are also problems that can occur in the deployment phase. And to this regard, is interesting a discussion that I was having a few years ago at a conference, because after my talk, I think I was discussing during the coffee break, during the old times when there was a coffee break in the face-to-face conferences. I was talking with a guy that, if I remember right, he was working for the bank UBS. I'm not completely sure. Here I put picture of UBS, but I think he was working for some bank, most likely UBS. And he was telling me that, well, for his specific job, the really only concern was the deployment, because he said, well, our software development can be outsourced anywhere. We will outsource it for little money. We will get it pretty much correct. We have reliable partners. And then, for example, for the case of the ATN machines, that was his job. The problem was to deploy it. So that was the complicated thing. It was the essence of his job. And probably the only time that I met a person that was doing this job, and made me think about the change in perspective that especially we are seeing this now in recent years, where deployment shouldn't be neglected, because deployment is a major issue. And this is the moment in which we had this appearance of DevOps to eliminate the barriers, so reducing basically the time to market without affecting the quality. So how we can reduce the errors during the deployment, or managing the incident in an effective manner. So ultimately, to speed up not only the development, but to speed up the deployment. That is important part of the software engineering process. Probably you already know, I will mention some ideas about DevOps, but probably you already have heard about it, because it's a keyword for already more than 10 years. And a lot of literature was produced, books, so it shouldn't be a new concept. But this idea is focusing on three things. The process that we mentioned before, so the software technology, the tools and the technology, therefore the automation. It is necessary to improve the development and the deployment, also to have a better automation, to rely less on the human intervention. But this is part of the automation process that I was mentioning at the beginning. We are automating more and more. But the interesting thing that the DevOps movement is not denying is that, yes, we want better process. Yes, we want more automation, but we have to realize that for a company to be successful, you need to have a specific culture, a specific environment there regulating the people. So there has to be a shared set of values. So this is also part of the DevOps training, is understanding the philosophy. The idea is to eliminate the barrier between the people developing software and the people operating the software. The first time that an idea like this came was inspired, was basically a consequence of the agile movements. Okay, agile movement was focusing on processes, and then at some point someone started thinking about infrastructure, deployment, operations, and so it was called agile infrastructure. Well, basically, frustrated engineer understood that nothing was working in the company. The problems were between the developers and the operation teams. And he was a member of the agile community. So how we can extend this idea of agile into the infrastructure? So later this term was called DevOps, but initially it was called agile infrastructure. And finally, so in the last phase of this talk, I want really to narrow down to what exactly we are doing in such a large context of DevOps. So in this project, we focus on the DevOps, the anomaly detection, the machine learning, to some extent less on the process mining. So this is the focus of our current project. What we want to do. So we got inspired again from existing problem. The problem is the transaction anomaly detection. There is a lot of literature about it. You can read entire books on the anomalies detections, and transaction anomaly detection is one of the specific application of it. So I found my card blocked quite a few times, especially when I was living in Britain, and I was using less my card. Now my card, now I'm pretty much cashless. I mean, there are pros and cons about it, but I'm pretty much using card very often. But when I lived in England about 10 years ago, it was different. I was using the card occasionally. I was using mostly cash. So many times I had the situation in which my card was blocked because of unusual purchasing pattern, which is normal, because if you never use the card, the time that you use the card, you probably buy something that for a significant amount of money that it's outside of your pattern. So, well, okay. So we have a lot of literature on anomaly detection. We understand that it works very well in the bank system, so that, I mean, if banking are relying on it, it means that it's pretty effective. It's getting better and better. However, there are false positives, because every time that my card was blocked, it was not meant to be blocked. There was no burglary or anything stolen. It was just unusual pattern generated by me, but you are ready to pay this price. You are ready to pay with the fact that sometime your card will be blocked. Is a false positive, provided that you know that your card will also be blocked when there is a real problem. So maybe someone stole your card. So this is something that we started from this idea. We said, okay, can we do anomaly detection on the releases? So we need to identify some metrics such that these metrics can identify possible problem occurring in the release. So some unusual behavior of the developing team that is releasing something that is strange. Now we will see what it means. No? So if this something is strange, in the context of continuous releases, you can save a lot of time. If you have an automatic system telling you, look, strange, you know, today your commit, it's different than usual. So probably there is some mistake, like in the transaction for banking system. So yes, we are in the context of DevOps, and in the context of DevOps, one of the beautiful things that you have is that you have a tool chain that is doing automatically a lot of things, and at the same time that it does these automatic things, is generating huge amount of data. So release, DevOps, data. So you start saying, okay, what we can do with this data? Maybe we can use machine learning to identify some strange behavior automatically, or at least semi-automatically, so that we can raise a flag in case there is an issue, so that the system will go back to the developer and say, look, your release is strange. Is this what you really mean, or you want to change something? But the most problematic thing here is to identify the metrics, the soft metrics, that could indicate potential risk in the release, in the future release. So now I will show you some example, because we started experimenting little. So we have some example of metrics, but in theory, you can think of any metric. The most trivial, probably also the least meaningful metric that you can think of, is the line of code. It's not very meaningful, and usually line of code is one of the most misused metrics in software. It has been used even to the point sometimes to reward or to punish the developers, which absolutely, as a developer, you know, makes absolutely no sense. But managers like metrics because they want to set up incentive systems on the metric that are easy. So it will be easy at some point to say, if you write less than 50 or 100 lines of code in one day, you get punished, or if you write more, you get reward. But as you know, every time you set metrics, if you set a metric as a criteria of productivity, people immediately understand how to cheat it. Or maybe it can be failures in staging, or maybe it can be other metrics. But if you identify one, let's imagine line of code. If I release software every day, my software has a new release every day, for example, or typically in the DevOps context, many times per day, every few hours. But let's imagine this every day. And typically I release 500, 600, 200 lines of code every day. And one day I release 2, or I release 50,000. Maybe this could be an indicator of something strange, or maybe not. Okay, because line of code by themselves is very poor metric. But even thinking of such a simple scenario, you may say, okay, so your system automatically would go back to the developer and say, look, usually you are releasing 200 lines of code, and today you're releasing 50,000. What's happening? Is this what you really want to do? So you understand that we are doing basically, we are now in the domain between software engineering and data science, or in particular, if you want, data mining applied to software. But this part is not very well developed yet. So what we think is that if we produce a good system for anomaly detection in release, ultimately this will become a very, very important tool for analysis of business processes and for process management. But we are not yet there. Okay, we are still in the first stage of the work. What we have is a large quantity of generated data generated by the toolchain. So this is what we have. And we have a set of algorithms and a large literature on anomaly detection. So what we can do? As usual, some humor also helps to focus on our problems. So what is the latest on the software release date? Well, we are right on time for the pre-alpha launch, unless we run into something unexpected. How often that does happen, and whenever I need it. Okay, so as you know, this is always funny moments of Dilbert that are related to technology or to software. And I often show also in my course in requirements engineering, for example, some of these cartoons, because they are very funny of showing how sometimes this is a kind of caricature, but sometimes the realization of the process is way less ideal than what we think. So you probably have heard about algorithm for anomaly detection before, but if you want to be more precise, an outlier, that is also called anomaly, is a variation from the expected norms, while the inlier is data that is non-anomalous. So if you see this picture here, you see, for example, whatever the value is and whatever the time is, at some point here you have an anomaly, something strange. The reason that why this is strange should be detected by the human operator. Okay, typically there are two general ways, or a combination of both, or a combination of them to determine what is an outlier: the expert knowledge and the ML algorithm, all together. Now you understand that if we want to rely on this large amount of data generated by the DevOps toolchain, it's very undesirable, very inconvenient to rely on the expert knowledge. So we want this stuff to be, to some extent, automated. Okay, so we have some releases that may represent the outliers, and we want a system able to detect when there is a variation from an expected pattern. So then this information communicated to the developer will help them to take in further decision, to do further testing, or maybe say, no, it's correct, I want to release it like this. I want to go already in the deployment phase without doing anything. But most likely you want to do more testing before the actual release. Because we don't do cowboy codings. So we don't, so the instruments that we are offering are instruments that are avoiding as much as possible the so-called cowboy coding. So where basically people put their hands on the development, they don't take much care of the design phase, they take care even less of the requirement phase, testing maybe sometime, maybe not in a very well organized manner, and then you hope that everything goes well when you go into production. So we don't do this. Probably you know the idea of DSP, so development, staging, production. It's basically the staging is a model in which you have this staging environment between the development and the production. The staging environment is a replica of the production environment. So is actually duplicating the production environment. You're using the same hardware, the same software, the same setting. So everything that happens in the staging environment will 100%, if everything is set correctly, what happens in the staging environment will also happen in the production environment. So you have this kind of in vitro environment that before going actually in production, you can do the testing, so to see if there is any problem. Okay, and this is what we call no cowboy coding. So less adventurous way of coding. Cowboy coding is a kind of adventurous coding manner based on talent. At some point in our life, I think all of us went through this. Typically, when you start programming, I started when I was 12. Maybe other people start 15 or later. You start as a cowboy coder. I don't know personally. I don't know anyone that started coding as in an organized manner. I mean, by the book. Usually, when you come to the university, even our students, first year, they are 17, 18 years old. They all come with some coding experience. I never seen anyone that comes without coding experience at all. If you have zero coding experience, unlikely you would go to study computer science. At least this is my experience. And the coding experience that you have before coming to the university or to the school is cowboy coding. So then the rest of your life, you have to learn how to do things better. So I learned, other learned, so probably everyone can learn. So what is the idea of our research? So in order to reduce the risk of problems in production, an anomaly detection system will operate at the staging environment to compare a release with the previous ones just before going into the production. So there is a typo here, to compare release with previous ones. So you compare with more than one, just before going into the production. This is why it's important to have the staging environment where we can do this in vitro analysis. So how the flow looks like. And I will show you also a diagram, a diagrammatic representation to make things simpler and more clear. But if the system doesn't detect any anomaly, and we will see better what we mean by anomaly, specifically what metrics should be used. If the system doesn't detect any anomaly, probably the risk of having an issue in production is low, because we would expect this issue to appear also in the staging environment. But if there is such an anomaly detected by the system, then that release should be suspended, should be sent back to the team, to the development team. They should be alerted that something should be done, and they should do further testing or further verification. So this is the idea. The operating flow looks like this. So the day of the release comes after a period of development testing. Your system, I will show you also the prototype of the system. So the system collecting the metrics that we instructed it to collect, and you run this anomaly detection. If you don't detect any anomaly, you can release. If you detect some anomaly, you need to alert the team to do something. Then the humans will check for the real problems. If there are no real problems, you can do the release. This time will be done manually. Otherwise, you suspend the release until the problem is fixed. So simple flow chart to understand the idea. And again, this analysis cannot be done manually, should be done computer-based, should be done automatically, should be done by machine learning algorithm. But we don't want, and actually we cannot, and we don't want both replace completely the human. So what we want to get is a synergy between machine and human. So we will have a human-made assisted decision. So the system will help the human to identify the problems for the developer. So this is what we want to do. And manual inspection being impossible, since the logs of the tool chain is just too big, we need to do this automatically through well-known machine learning algorithm. Actually, I will show you that in our prototype, we experimented more than one algorithm and we compared them, so to get some hints on this idea. Another note, I mean, comment that we can make here, because there is always the question, sometimes should be supervised or should be unsupervised. The anomaly detection done by machine learning algorithm can be unsupervised and can be semi-supervised. The unsupervised learning can be used to flag outliers in a data set. Why? So I say that the data is very large and you want to do this in the most convenient way possible. So basically labeling the data done by an expert it's not really viable solution because it wouldn't make things much easier, much better. So we really want to avoid this supervision. Okay, we want to do unsupervised machine learning to make things as much as possible convenient. So you see that now on the blackboard, there are already some keywords that are there, and our research is interdisciplinary, it's cross-disciplinary between all these research fields. So DevOps, process mining, anomaly detection, and machine learning. If you put them all together, so at the cross between data science and software engineering, what do you get? No, you don't get a unicorn. You get something that really exists, can be done at least. And in the last part of the talk, in the last 15 minutes or so, I will show you a proof of concept, because now, I mean, we started from very large visionary talk. We discussed about the DevOps, about the philosophy, about the problem of anomaly detection. And then, okay, ultimately, can we do this thing? So at least we tried, we did it. So we have a prototype, we have a proof of concept of this idea that we plan to develop in the close future. And now I'm going to show you. So what we did a very simple. So first of all, we were in a kind of loop, because 1 year ago when we were at this stage, the idea was, okay, what we can do? Well, let's go to some company. Let's get, so very naive, no? Usually you start in a very naive manner. Let's go to some company, maybe here in Innopolis Technopark. They are using DevOps, probably, some of them. Let's get their data, good. And let's do the prototype on the data. So let's do the anomaly detection on their data. But it ended up not to be so easy, because when we went to the companies, they were saying, interesting, can you show us? You see that there is a kind of snake eating the tail, because they say, can you show us how it works? But we had nothing, so we couldn't show anything. So if you don't show anything, they don't give the data. It's as simple as that. So to convince them to share their data, you need to show that what you have could work. Okay, but then how you can have something that works if you don't have the data? Because you need to do some experiment. So it's always this, in machine learning, data science, the problem is always to have interesting data, to have meaningful data. Okay, so after the first very naive approach, we tried another approach. We say, okay, let's do our app, kind of simple app. Let's set up the tool chain. Let's collect some data. Let's do some analysis, and let's do a prototype. Then with this prototype, we go back to the same company, and this is what's happening now. You go back to the same company, you show the prototype. They understand this is a proof of concept, it's a kind of toy example. But what's happening now, that the attitude really changed, because before you go without anything in your hands, and then you go with something. And now the probability to get interesting data can be solved. So the next step actually is to do analysis on real data, because here is artificial data, is data that is created exactly for this purpose. We created a very simple application based on NASA APIs. This application is called Space Viewer, and we have the Space Viewer anomaly detection system that we call SVADS. And yeah, you can visualize information and picture and text about space missions in this application, something very simple. But it's just an application, because we don't really care much about this application. What we care is to set up the tool chain and to collect the data. So the technological stuff here was done using Python and using library Python for machine learning, in particular for LOF algorithms, setting up all the classical tools of the DevOps tool chain. So this was done. We used, of course, the DSP model, because we want to do the anomaly detection on the staging system, on the staging server. And then the discussion was, the key discussion here that I introduced already before is, okay, but what metrics we should use, what metrics we should extract here to identify the anomaly detections. In the charts that I will show you, in the prototype and in the analysis that we have done so far, we are not using all these metrics. So this is why it's work in progress still. But these are some of the metrics for example, some of the metrics and the specific tool that is collecting data that could help in measuring, identifying this metric and identifying anomalies on this metric, including issue on GitHub, including the failed automatic test, including the lines of code. Okay, and probably more work should be done here in identifying metrics that are suitable. So you really want a system that can analyze large number of metrics and provide reports on all of them and identify anomalies on a large set of metrics. But in general, all these metrics can help a statistical model to identify the risks. So here you see what happened in the development, in the staging, and in the production environment of our system. What we did, so we developed the application, of course. In 1 month, we collected the metrics. So we did 25 releases of the application. For the first 10 releases, we just collected. Okay, so we didn't do any analysis in the first 10 releases. We did only after the release 10. So to have a set of data, a data set that was, although small, significant to make some analysis. And after this, we ran the anomaly detection. Okay, this chart is more or less the same chart that I showed you before. It shows the same idea, just representing how the different moments are allocated in the different servers. So let's see what in the last few minutes that we have. I think I have 10 more minutes. Let's see a little bit what we found out. Then I will show you another chart with the further validation. But initially, we utilize this local outlier factor unsupervised algorithm. And here the data is not labeled. Indeed, I explained you why we don't want to label the data. We really cannot, and we don't want in any case. So you see on the x-axis, you have the quantity of committed lines of code. Here I'm showing you very simple metric. And on the y-axis, you have the numbers of tests that failed. What do you see here? You can see even visibly that, okay, the greater the score, the greater the possibility of containing an anomaly. But there are 3, 4 of these releases that are numbered, the 15, 18, 22, and 24, that are strange. This chart now is a bidimensional chart. So for good visualization, we are representing only 2 metrics. You imagine that you can have number of charts, or maybe you can even have 3-dimensional chart, so that you can identify using multiple metrics those releases that are even more likely to be anomalies. So here there are 4. You see 4 strange situations. So okay, then but maybe let's see if it's some specificity of the algorithm. So we studied the literature, in particular my colleagues with experience in machine learning studied the literature, and they identified 4 algorithms for ML algorithm for anomaly detection that in theory, in principle, should have shown the same results. And indeed, if you look at the charts, the strange releases are always 18, 15, 22, and 24. So the validation confirmed the result at least in 3 out of the 4 different systems. There is only an exception for release 18, because if you see the robust covariance, the release 18, it's not identified in this specific case as an anomaly. So what is the limitation here? You see the data set is extremely small, but of course I know every data science problem, every machine learning problem is living out of the quality of the data set. But here we were in this loop in which we couldn't get data set until we show the prototype. So this is why we create our own data set based on a simple development experience of a simple application. But still, you see, something is happening there. There is something interesting that we can see. Now, to wrap up, because before concluding, I want also to raise a couple of questions for you to wrap up all the thoughts. So what is interesting here? Well, I want to emphasize one, we could talk longer about this, but I want to emphasize one point that is necessary. This analysis like most of this kind of analysis, even when we discussed before the bank transaction anomalies, as false positives and false negatives. So this analysis cannot be 100% accurate. We don't expect this to be 100% accurate. In a future study, we will have to understand better how it is accurate. At the moment, we don't have enough data, enough evidence to say it is 99% accurate or 98%. We would like to have a very high accuracy, 90 something, obviously, probably more, but we know that we cannot have 100%. We need always the human inspections. So we will always have false positive and negatives. Future work, when we will have a larger data set, probably from actual company doing actual work, commercial work, we will try to see how far we can go with accuracy. So this is something very important to take into account. So to summarize, and then I'll move to a couple of final thoughts. We are using the machine learning to support the DevOps automation and the continuous releases. In a context of continuous releases that I told you how important it is and how it is relevant. So now we are moving the attention from development to deployment to the releases for the number of reasons that I explained before. We want, we accept, and we understand the decisions are human-made. So the system is not doing decision. The system is assisting, but is not doing decision. The decision always back to the developers. And the key point now, the next future work, the future step, is to really find larger data set from industry and see how strongly we can validate our claim. So now our claims are that this approach is valid, that can identify in a good manner, in a relatively precise manner, the anomalies, that the decision is always made by the human, but that the human can rely the system to have a accuracy close to 100%, although it cannot be 100%. Okay, so from the large to the small, let's go a little bit in the last couple of minutes again to the large. So we are in the position now, I think, maybe I'm shooting too high, but I think we are in the position to hack the world. What does it mean, hacking the world? So now we have ability to store data and to analyze data like never before, depending on computing power, but in general, we have pretty good computing power. So look at this informal equation that shouldn't be taken mathematically, because obviously plus and equal here don't have the meaning that we mean in mathematics. But domain knowledge plus computational resources plus data is equal to forecast power. What does it mean? If I have an experience, in this case, human experience on a specific domain, in this case is DevOps, software development, but it can be anything. I have enough computational power, memory, processor, and so on, and I have enough data, relevant data, I can really predict the future. I mean, not like in Minority Report, but okay, think about Minority Report movie and think that you have a domain expert. I think there it was police or something like this, if I remember vaguely this movie. You assume to have the data that you collect from the behavior of the people. You have the sufficiently strong computer. You can predict with some accuracy. Again, it will not be 100%. It will be 99, 98, 95. You can predict with some accuracy what this person will do. I mean, that movie, again, to go back to close the ring, you see that everything is closing now. To go back to the first thoughts that we had at the beginning of the lecture about Minority Report as a movie, who is inspiring who, we kind of have the seeds of the technology to do that kind of thing. And immediately now, you will think about ethical consequences. Because, look, we really can do this. I mean, not right now, we may not have the data, but imagine that you can monitor several perspectives of the behavior of a person. Movement, heartbeats, and position, purchases by credit card, face recognition, a number of things, okay? And you can really have the right algorithms, and therefore the domain knowledge of, in this case, was police. You can kind of predict the behavior of people. People generally are not that unpredictable I mean, on average, no? Of course, there are very unpredictable people, but even these more unpredictable people, like criminals that are more unpredictable, their behavior could be predicted. So the system knows about us, about our activities, better than ourselves, because we forget things. You don't remember where you were on 13th of April 1997. You don't remember this. But a system that monitored you, in principle, could know. So I think we can really predict action. I mean, maybe not yet as in minority report, but in situation like anomaly detection, you see that you potentially can do pretty accurate analysis. So going back to the idea of software engineering, after this long talk about cinema, literature, arts, technology, and finally software engineering, if we have this possibility to hack the world, how can we use this knowledge and this technology first to help the developers to understand their mistakes and to become better developers, but also, and here this is my last slide, and I want to go back to almost the first to close the ring, to close the loop. You remember what we do at Innopolis? We do two things. We do research on IT and we do education. So now, to connect the educational part and to open a potential second lecture for the future, how we can use this knowledge to better educate the students, to identify their mistake in the learning process, but also the mistakes of the professors in the learning process, and therefore develop systems that could assist their learning in some way. So now, I mean, I'm generalizing again our results, because our results are very limited to the releases of software. But I think continuing this research and finding more validation to our results can then inspire us to apply this knowledge, cooperating with domain expert of another domain like education, can help us in finding answers to these questions. So, Sergey, I stop here. I think I took 2 more minutes maybe than needed, not than needed, than I had. But I'm available for discussion, questions now, later, anything.